Alright, we're back with a new video today talking about all things angles. So, by definition, we talked in a prior lesson, angles are two rays with a common endpoint. Now, the vertex of an angle is pretty important, and this is the actual common endpoint. So recall that an angle looks something like this, and this right here is the vertex. That little piece right there is the vertex, that's the common endpoint. Alright, there's four types of angles. Some of this you guys have heard in the past. Acute angles are triangles that have angles less than 90 degrees. An obtuse angle is one that is bigger than 90 degrees. A right angle is equal to 90, and a straight angle is equal to 180. And this is what we call a straight line as well. Okay? Alright, so a special type of angle we have is called a vertical angle, and by definition, vertical angles are opposite angles formed by two opposite rays. So essentially what we're talking about is we have two lines intersecting, and the intersection creates a vertex, and each opposite angle is equal to each other. So in this diagram here, this angle and this angle are the same measure. If this is 40, this is 40. This angle up here, which I'm using two congruency marks, is congruent to the one below it. Vertical by name doesn't mean up and down. It actually comes from the French word vertice, which is where it comes from, because the angles all share the same vertice. So understand, vertical does not mean up and down. It just means they share the same vertice, but they're across from each other. So think of two lines intersecting, forming an X, and you're going to have angles. Now the theorem tells us that they're equal to each other, which is what I said a few seconds ago. So the property of vertical angles, and this is really important because you'll see this throughout the rest of the course, vertical angles are congruent, they're equal to each other. If this is 100, the vertical angle is 100. Okay? All right, so in this problem here, we're gonna take it a little further in complexity, and it says find the value of x and then figure out what A and B is. So we have to ask ourselves, all right, what do we know about these angles? First thing, what is this part? This part is a vertical angle. So we have to be able to identify the part. Then we have to know the property. The property is they're congruent. So what we're gonna do is set these two equal to each other. This angle is equal to this angle. We use our equation solving steps, and we end up getting x equals 52. That was the first part of the directions. The second part tells us we need to find the measure of the vertical angle. So what this means, we have to take x and we have to plug it in to the equation and solve. Now, because these two are both equal, it doesn't matter which one we plug into. I'm going to choose this one because the math is a little bit easier for me. So I'm going to do 2 times 52, which is 104, plus 3 gives us 107. So if this is 107, this is 107. Right? Now they want you to find the measure of angle A and angle B. Well, A and B are congruent because they're vertical angles. But what we talked about a second ago is that we have these angles called straight angles. And these are angles that add up to 180 degrees. So anytime you have a straight line, those angles are going to add up to 180. Okay? So if this is 107, we're going to subtract 180 from that angle and get 73. And that's going to bring us to a further topic coming up. We have this term called adjacent angles. Adjacent angles means next to, right? So in this case, angle 1 is next to angle 2 and next to angle 4. Right? Angle 3 is next to angle 2 and next to angle 4. Angle 4 would be next to 1 and 3. So that just tells us, that just identifies the angle. There isn't really a property except that they share a common side or vertex. But numerically, there's no property. It's just identifying that. But there are some things that we can use with adjacent angles, such as this. In the past, we talked about maybe a segment addition postulate. In this case, we're talking about the angle addition postulate. And this comes down to this. We have two parts of this angle, or maybe even more, but in this example, we have two parts, and it equals to the whole thing. So part plus part equals the whole thing. So this part plus this part equals the whole. We've seen this in the past and we'll continually see it. Now, what is unique about this postulate is that we have some special cases. So the first special case is what we call complementary angles. This is where we have two angles who add up to 90 degrees. And so that would be an example of this here. Now, we can make it more complicated by throwing in an equation, and we'll see an example of a similar problem down here. But that is what you have to know. So if you have a complementary angle, it equals 90. A fun little way to know this is that if you have a complementary angle, that C almost becomes a 9. All right, so if you watch again, the C makes a 9, and that's why you know complementary is 90 degrees. Okay. All right, the next is called the linear pair, or supplementary angles. All right, and these are two angles that form a line, and they total to 180 degrees. This is what we used on the prior problem. So these angles are called straight angles. Here would be an example of that, where we have two angles, and all together they add up to 180. So part plus part equals the whole thing, which is 180 degrees. This is something that we see so much in this class. You'll use this over and over again. All right, so here's an example where now it's not just numbers, we're gonna use equations. So we need this. So if they say A and B are complementary, what does that mean? That means that this part plus this part is equal to 90. Okay, so we're gonna have, 90. Made an error there, okay? All right, so we have, in this problem now, we have 5x minus 10 is equal to 90. We combine like terms, all right? And then I add 10 to both sides, and I get 5x equaling 100, x equals 20. But that doesn't tell us what we want here, because it says find the measure of each angle. That's not the angle, that's the variable in this problem. So what we have to do then is plug in the values. So what is angle A? It's 3 times 20, which is 60, plus 12, which is 72. Okay, for angle B, it's 2 times 20, which is 40, minus 22, which is 18, okay? And then 72 plus 18 would add up to 90. Now, there's one other way to find angle B. If we know angle A is 72, we could also take 90, because they're complementary, and subtract 72 from it and get 18. So either of those cases would be fine in that case. So that takes us through some angle questions with equation solving. All right, so now we get into this topic called bisecting angles. In the past, we bisected a segment, and that created a mid-segment where we had two congruent segments. In this case, we have an angle bisector. It's going to split an angle into two congruent angles. So in this picture here, this ray is the angle bisector, and it creates two congruent angles. So in this case, this angle is equal to this angle. So this part is 40, the bottom part is 40. And then we're going to use the same issues, or the same properties, solving with equations. So for example, we have something similar here, that if it tells us QS bisects this angle, right? So that means the top and the bottom are the same, and then we have PQS. PQS is the top, that's the part. So they want you to find PQR. PQR is the whole thing. Okay, so we have part and the whole, and we've talked in the past that part plus part equals the whole thing, right? So we know by the property that this other part has to be 24. 24 plus 24 gives us 48. So that explanation explains all these words here. Okay, so we have to know what is given in here. We have a part and the whole thing, and then understand the properties of angle bisectors.